Hello students, welcome to Engineering Mechanics course. Today in this class we will see resolution of force. We will also discuss how to find out x and y components of a force, which are also called as rectangular components of force. So resolution of force is a process of splitting the forces or dividing the force into two or more components. One single force, when we split into number of components, that process is called as resolution of force. Of course, this number of components has the same effect on the body that the single force would have created. So, in simple words, resolution of force exactly opposite process to resultant. If you remember what we are doing in resultant we are replacing number of forces by a single force, right? If you see this example, one body which is subjected to four different forces, like this is F1, F2, F3 and F4. Four forces are acting on a body, and if you replace these four forces by a single force which has the same effect on a body what those four forces having, the single force is called as resultant. Okay, so in resultant we are replacing number of forces by a single force, whereas in resolution of force exactly opposite process we are doing. We have a single force and we are replacing that single force with number of components or number of forces. This is called as a resolution of force, and first one is called as resultant of force. So we can replace or split one single force into n number of components. Okay, that is called as resolution of force. But most commonly, to find out the resultant of force, okay, during the process of resultant of force, we are resolving a single force into rectangular components, which are also called as x and y components of force. Okay, so in this class we will discuss how to find out x and y components of a force or rectangular components of a force. So in resolution of force into x and y components, if you take an example here, one irregular body is shown and one force F is acting in the first quadrant, making an angle theta with respect to positive x-axis. This is x-axis plus x and this is y-axis coordinate system. So we are considering one force F which is in the first quadrant, making an angle theta with respect to horizontal axis, that is x-axis. Now if you want to divide or resolve this force F into x and y components, so you have to draw one horizontal line from the point of application of that force. So we have drawn one horizontal line here, and similarly we have to draw one perpendicular in vertical direction, that is y direction. So if you look at this figure, we have drawn one horizontal line, okay, and one vertical line, which makes one triangle here. This is angle theta made by this force F. Okay, this is given force F. We have drawn one horizontal line towards right, one vertical line upward, which makes an angle, one triangle. Now question is, what is front side of this triangle or opposite side of this triangle, and what is adjacent side of this triangle? Values of these two sides we have to determine. Okay, so if you apply a simple trigonometry to find out opposite side of triangle or adjacent side of triangle, we know that if we use sin theta formula, sin theta is equal to opposite side which we have to determine. Let us assume this side is equal to y. Okay, so opposite side is y divided by hypotenuse or diagonal which is F. Okay, this is F, which is given force, represent the diagonal of triangle. So what is y equal to? Y equal to, if you take F on left hand side, it is F sin theta. So this is value of y, F sin theta. Similarly, if you use the cos theta formula, cos theta is equal to adjacent side, which let assume this adjacent side is equal to x. Okay, so adjacent side divided by diagonal, that is hypotenuse F. So what is x equal to? If you take this F on left hand side, x equal to F cos theta. So finally, horizontal side of the triangle which represent the x component, its value we got F cos theta, and vertical side which represent the y component, we got its value F sin theta. So these are called as x and y components of force F if it is in first quadrant of the coordinate system. So since it is in first quadrant, x is taken as a plus and y component is also taken as a plus, because first quadrant represent plus signs of x and y coordinates, second quadrant represent minus signs, third quadrant represent minus sign, and fourth quadrant represent plus minus sign of x and y components. So following these signs of the different quadrant system, since force F is in first quadrant here, our x component is plus, that is towards right, and y component is also plus, that is upward. So this x component is equal to finally F cos theta. If you look at the third figure here, this one, so this is the point of application of force. If it makes an angle theta with respect to x axis, then x component is taken as a F cos theta and y component of force is taken as a F sin theta, where F is the given force and theta is the angle with respect to horizontal, or it is also called as x axis. Please remember, if theta is with respect to x axis, horizontal x component is cos theta and y component is sin theta. It is very important to understand. If theta is with respect to x axis, x component is cos theta and y component is sin theta. Since F is in first quadrant, this is x is plus, y is also plus. Now the second probability is, maybe angle of force F may be given with respect to vertical axis, that is y axis. So if angle with respect to vertical axis is given, if you see this figure, this is force F, okay, which is represent the hypotenuse of triangle. This is F, sorry, this is force F. So if you draw horizontal line from this point and vertical line, and this is angle theta. So if you prepare one triangle with this angle theta, this is the triangle. Okay, now in this triangle, opposite side represent the sin theta here. If this is angle theta, opposite side is this, that is x component, which is plus towards right, and adjacent side represent the y component, which is upward, that is plus. Now opposite side is horizontal, so this become sin theta, and vertical, that is y component, becomes cos theta. So if you compare the two figures here, if you compare these two figures here, this is first figure and this is second figure. What you understand here, in first figure angle is given with respect to x axis, and in second figure angle is given with respect to y axis. So if angle with respect to x axis of force is given, x component is F cos theta and y component is F sin theta. If angle with respect to y axis is given, y component is F cos theta and x component is f sin theta. So while resolving the force into x and y components, you have to carefully see that angle is given with respect to which axis. Okay. Now we will take the all four possible examples if forces are given in different quadrants. So these are the four examples. This is first example where force is given in first quadrant. In this example, force is given in second quadrant. In this example, force is given in third quadrant, and in this example, force is given in fourth quadrant. Okay. So if it is in first quadrant, in all four cases, I have taken angle with respect to x axis here, x axis, x axis and x axis. So if force is in first quadrant, x component is taken as a plus, that is f cos theta, and y component is taken as a plus, which is f sin theta. If force is in second quadrant, that is x component is taken as a minus and y component is taken as a plus. Value of x component is f cos theta, value of y component is f sin theta, but x is minus in second quadrant and y is plus in second quadrant. If you take the third example where force is given in third quadrant, so f cos theta, that is x component is taken as a minus and y component is also taken as a minus, because third quadrant represent minus signs of x and y. So both the components are minus. In first quadrant, both the components are plus. In second quadrant, x component is minus, y component is plus. Similarly, last case, fourth case, that is if force is acting in the fourth quadrant, x component is taken as a plus and y component is taken as a minus. Okay. So x component is f cos theta, which is plus, and y component is magnitude is f sin theta, but its sign is minus. So understand possibility, if force is given in first quadrant, x is plus, y is plus. If force is given in second quadrant, x is minus, y is plus. If force is given in third quadrant, x minus, y minus. If force is given in fourth quadrant, x plus, y minus. In all four cases, x component is f cos theta, y component is f sin theta, because in all four cases angle with respect to x axis is given, that is theta. And if similar case, if angle with respect to y axis is given, if you look at this, angle with respect to vertical y axis is, if it is given, then it is y component is cos theta and x component is sin theta. So f cos theta and f sin theta are interchanged in all four cases. Y component is cos theta, x component is sin theta, because angle with respect to vertical axis is given to us. Signs of resolved components are same. If it is in first quadrant, x plus, y plus. If it is in second quadrant, x minus, y plus. If it is in third quadrant, then x minus, y minus. If it is in fourth quadrant, then x plus, y minus. So this is when theta is with respect to y axis is known, and this is when theta with respect to x axis is known. This is called as x and y components of a force or rectangular components of a force, and these are the most commonly used components if you want to find out resultant of force system using analytical method or using rectangular components. I hope all of you have understand how to find out x and y components of a force. In the next class, we will take one example on resultant of force system using x and y components of forces. Thank you very much.